So we're going to be running through a little bit of the content from the R for Data Science, specifically the data visualization section. Now, the way this book is set up, it's in this data visualization section, it actually has some asides about some of the basic things you've already learned because we're doing it a little backwards from the way the data for R for Data Science is set up. So you should read through this after the lecture. It's going to talk about things in a little bit different way, though. So to talk about visualization, I first need to tell you about a new sort of thing in R that we haven't dealt with yet, which is the thing called the data frame. So we've talked about creating objects in R. You can create an object that is a letter or a number. You can create an object that is a string. You can create a, not question mark. You can create an object that is a logical value. So let me actually create all of those, and I'll look at the environment here, and I'll see that those were created. One, hello, true. Interesting. I thought this had usually, maybe if it's larger, it shows what it is. All right, well, okay. And we talked about creating objects that are like a concatenation of multiple of those basic data types into something that I kept referring to as a vector. Which, if we again look at our environment, there's the object D, and it's a bunch of numbers. So there's another object that is probably what you'll be using more commonly than these individual sort of primitive objects, which is a data frame. A data frame, you can think of data frame just like a spreadsheet. It has rows and columns, and it's structured such that the columns should all have entries of the same basic type. So a column can be all numbers or all strings or all logicals. There's another thing called a factor that we might deal with, actually, with the tool. Yeah. Factor is just when R recognizes, or when you want to say there's a string here, say it's a column indicating the sex of a patient. Usually you're only going to have males and females in that column. So instead of having our remember or having to sort of store the string male and female associated with every single column, you can actually tell it there's only going to be males and females. So it's going to, behind the scenes, just put ones and twos in that column. And it will just know that whenever it sees a 1, it means female, and whenever it sees a 2, it sees male. You can change like the ordering of those labels, and I don't think we'll be really using that in what we're doing. So we're using a few newer tools than what I've taught in the past, and I'm used to having to go through factors, and there's some complications about using factors that I guess we won't have to deal with, so that's nice. But a data frame, it's like a spreadsheet. So one data frame that is already built into R, what's it called? Is it called Iris? Yes. So if I just type in my code here, print iris, I haven't created anything called iris. It's not in my environment here, but R doesn't complain. It actually prints something. Now, what it prints is actually hard to look at. Maybe I'll resize this a bit, and I'll tell it to try again. Print that. Okay, so I get this big sort of table-looking thing. So this is what happens when you try to just print a data frame. It literally prints out the whole data frame. So it shows you all the columns, and it shows you all the rows. Up above, when I tried to print it with a smaller window, you'll notice what happened. We're getting all these values. It looks like we've only printed one column. But once we get to the top of this column, we'll see that, oh, we see all the other columns. So if you have your window sized such that it can only fit sort of a subset of the columns, it will print that entire subset of those columns, all the rows for that subset of columns, and then it will move on to the next subset of columns that will fit. So it only had one more row to have, or one more column to have to print, so it showed that. Usually you won't be looking at data frames like this. There is a way, let's see, to take a look at the data frames in a little bit nicer format. It'll look a little bit more like you'd see in an Excel spreadsheet. If you said view iris, the view pane will, or a view tab will come up in your source area. And so you'll actually see there's a nice header column there. You can actually sort with this, but that won't change the underlying sorting of the object. So this is sort of a read-only view of the data. So you can...
So is this a pre-populated data, or is it...
Yes. So this is something that was built into R, is sort of hiding behind the scenes and available for you to use. You could always overwrite that object name, iris. You could use that, say I wanted to store the iris equals 5 times 8. That would create a new object called iris that has the result, let's see, of 5 times 8. So I've actually now lost the ability to look at that data set that's built in because I've overwritten it. But if I delete, if I remove this thing that I've created, so I'll say rm, which is the remove. This is stuff that you'll almost never do. I'm just demonstrating something about something a little wonky about workspaces and how R works. There's sort of like a hidden workspace environment behind the scenes. If I remove iris, it's gone from there. Now that default iris is available to look at and use again. So
how this data was entered if it's a pre-populated one?
Exactly. We're not talking about data entry yet. Yeah, I just wanted to, in order to show you some visualization, I wanted a data set that had already been read in. So we're using this one that's already there. So I actually consider that a little less than ideal to have things in your environment that you haven't asked for. But that's how R works. So I'm going to delete this. So we'll deal more with data frames, reading in data into a data frame in, I think, the next class, if we have enough, if we get to it, get through enough content today. But for now, one sort of slightly less than optimal thing about data frames is that, well, no, I'm going to leave that to next class. So far, we're just talking about data frames. So the next thing I want to do is do some visualization of sort of this iris data set. So actually, I'm going to pull up that view again. So we've got this data set where we have 150 entries, rows, and 1, 2, 3, 4, 5 different columns. The data set actually has a help page associated with it. So if I do question mark iris, I could learn a little bit more about this data set, where it came from, what these columns are. The column length, or the column names, are actually pretty informative. So it's talking about the sepal length and width. Does anybody know what a sepal is?
Is that like the sex part on the thing?
Okay, sure.
I don't know.
That sounds, because it's not the stem, it's not the petal, so maybe it's a sepal. Okay, but it also has petal length and width for 50 flowers from each of 3 species. So there's 3 species. I can kind of see in here Setosa, Versicolor, and Virginica. So 3 different species, a bunch of example plants from each of those species. So we can start to ask some questions sort of visually of this, like let's plot petal length and petal width. So we'll say I want to plot just a scatter plot of all the data, points for each row in that data set, and have it so that on the x-axis is petal length and on the y-axis is petal width.
If I create a data set, I can also create a help.
Pardon me?
I also can create like this question mark button for my own data set.
You would have to create a whole package in order to do that. That's a little bit more complicated. For your own data set, you would sort of have at the top of whatever R script that's associated with dealing with that data set, just a comment section that tells about what different variables are. Okay, so we can use built-in functions that come with R to visualize this data. So if I wanted to visualize this data, I would want the plot function. And so I'm going to put x equals and then comma y equals. So I need to give it what the x values are and what the y values are. In order to tell R to look inside the data frame iris and inside that data frame find the column named petal length, I do the following. I say iris dollar, and nice RStudio actually starts giving me suggestions for what columns I might want. So petal, and yeah, you can click it or hit tab and it auto completes. So iris petal length, iris, and I'll just go down then. So again, this $ means look in the data frame that's on the right, on the left there, and find the thing named on the right. It actually works for not only data frames, but other R objects that we won't be dealing with. But fundamentally, it means look at the thing that's on the left and find the thing that's named on the right.
So if you were to create your own data in R, you would name that set of data something,
yeah,
and then you could just do X.
Yeah.
Okay.
Yep. So the plot command, let's actually run it. And it creates a plot. Oh, because I didn't have this open, it was complaining. Now it'll work. That's one bug of RStudio that I don't like. So it's created a plot. This plot command is kind of useful for just sort of a quick visualization of data. It's not really, I wouldn't want to publish this plot. It's not very pretty. One quick trick, if you're using things on your own computer, I like to use multiple monitors and have like visuals on one monitor and code on another. You can click this zoom button and it actually pulls out a whole separate window that is tied to what's happening here.
Are you able to relabel your axes?
Yep. We'll get into that a little bit. Yeah. I mean, there are things that one can do to this basic plot in code to make it a little bit more presentable. We'll be using just a whole different package. Critically, this is just a picture. You can't click things and edit them in the pane. You can export, so save as an image, save as PDF. The difference between those, an image is something where once you save it, if you zoomed in, it's going to start to look blocky. When you save as a PDF, if you zoom in, it's going to be infinitely smooth. Most software, like The only reason you'd be exporting this is to put it in like a paper or something like that that's being written in some other software. Most other software will now accept PDFs as like importing images into it. So you almost should never use save as image. You should always use save as PDF. I'm pretty sure when you do copy to clipboard, it will create an image that's precisely this size. So that's also less than ideal.
Is there a way to change the
Aspect
names?
ratio, or sorry?
The names of the axes, so you don't have random
Yeah.
colors?
We'll get that in just a second. So yeah, I just want to demonstrate some sort of generic aspects of this plots area here. When you copy the clipboard, it's going to just use the dimensions that are right there, I think. Actually, no, it gives you the option to change the dimensions. If you click either of these other ones, it also gives you the option to save dimensions or change the dimensions and things. You can ignore this publish stuff over here because that's using more advanced features in RStudio for creating reports and pushing images to web pages and things. All right. There are ways to make this look prettier for publication, but they're pretty complicated and not very consistent in how you would use them. So I don't like using the plot commands. I instead use a package called Ggplot. So I'll go to my packages, find, there's Gtools, Ggplot. And it's actually called Ggplot 2. So I will load that. So Gg is grammar of graphics. There was a book written in the 90s, I think, on the general idea that all data visualizations inherently have a grammar to them, whereby you are taking data, possibly doing a transformation to it, but then mapping that data or the result of that transformation to some geometric object that then is placed in the plot. Here the geometric object is just points, but there's other more complicated geometric objects. There might be some transformations you do to the actual plotting space, like turning it into a circle or all sorts of things. But it is a way of thinking about data graphics that allows you to sort of have a common theme to a whole variety of different things. So bar charts, pie charts, scatter plots, line graphs, all these things have sort of an underlying commonality to them that once you learn how to create one type, it's easy to then create another type. So the library called Ggplot is one person's attempt to implement that grammar of graphics. You possibly need to install Ggplot. So you'd say install.packages and in quotes Ggplot2, and that would install it. You'd have to be connected to the net for installing packages to work, though. All right, so how does Ggplot work different from plot? Well, we're going to build plots by layering things together. So I'm going to store each thing into an object and then layer them together at the end. So the first thing you need for any Ggplot is I'm going to create an object. I'll call it, say, my canvas. So again, the name that I'm putting here is completely arbitrary. I could have called it that. I'm calling it my canvas because that's meaningful to me, because I know what I'm going to put in it is a blank Ggplot canvas. So when I call this Ggplot function without anything on the inside, it creates sort of a default object that Ggplot knows about, and when we later combine things, it will know how to to put things together. But you can think of it as the artist just coming out and putting out their canvas, and it's just blank. You can't, later we'll be painting things onto that canvas, but you need the canvas there in the first place to be able to put paint on. So the next thing I'm going to put is something that I'll maybe call points layer. So again, I'm just creating a new object. It hasn't been combined with the canvas yet. It's just sort of creating a set of instructions for later what to put on the canvas when we combine them. So what I'm going to put in this object that I'm arbitrarily calling points layer is a geom. There's lots of geoms available. In fact, in our studio, when I enter this, it gives me an auto suggestion of all the geoms available. Lots of geoms. The one we're going to do is geom points. So here we created a blank canvas. There's nothing, no arguments supplied to Ggplot, but we are going to give some arguments to geom points. So I'll add a new line here. So one of the things that this geom points is going to be a function that gives direction for how to plot some points on the canvas. So one thing that I need to do is tell it where to find data that it's going to plot. So the data is in the iris package, or the iris data frame. Next, it needs to know, so a point has a number of aesthetic attributes or just characteristics to it. It has a location, so it has a location on the x-axis. It has a location on the y-axis. It also could have a color. It could have a size. It could have a shape. If we look at the help for geom point, I'll go help, geom point. It'll be a help page. And I'm going to scroll down to a section that tells us what are all the aesthetics that are available. So aesthetics are visual characteristics. So there's X, Y. Alpha is computer speak for transparency. It goes from 0 to 1, 1 being opaque, 0 being completely transparent. Color, fill. Color is usually the outside line of things. Fill is what's on the inside. Shape, there's a number of different shapes available. Size is the different, well, of course, sizes. Stroke, I think, is if you've got a shape that has like an outline to it, it's like whether the outline is continuous or whether it's a dotted line. I don't use stroke very often. I have never seen it used actually. So yeah, let's do, right now all we're going to deal with is, we just kind of want to replicate this. So all we want to deal with is just X and Y. I'll show you use of these other aesthetic attributes later. So what we want to do is specify a mapping of those two aesthetic attributes to columns in the data. So the next argument happens to be called mapping. And mapping expects as the thing that you're passing to it as its value, a call to the function AES. This is the first time we've encountered, we're calling a function here, but now we're also calling a function in here. So this function call is nested inside this function call. So what R will do, I'll tell you about what we'll do in here in a second, but what R is going to do, it's going to come to this line, it's going to see that we're calling a function, so it's going to look at what each of the arguments to that function is, and when it hits this, it will hit this call to this function and run that. When it's done running this, whatever this does, I haven't told you about it yet, it will have some sort of result that in turn will be provided as the argument or the value for this argument mapping, which then will go on to, then it will go on, having whatever this value is to this argument mapping, it will then go on to run the function geompoints. So it resolves the functions that sort of are the innermost part of whatever nesting structure you have first, and sort of builds back out. So the AES function, you don't actually need to know much about it, except that it's a way of making a list. So we need to tell it that X maps to one column in Iris and Y maps to another column. So we actually tell it X equals, and what did we say, petal length. And instead of saying Iris petal length, we can actually just go ahead and say petal length. And again, I need to tell it a second thing. So there's a second argument here, Y. I put it on a separate line, put a comma at the front, equals petal width. So why didn't I need to put Iris dollar here? Because I've already told geompoint where to find anything referred to. So geompoints inside is smart enough that when it encounters a name that it doesn't think it knows yet, it will look in the data frame that you're providing here for that name. Okay, so we've created a blank canvas, stored it away in an object. We've created sort of a set of instructions for how to map, where to find some data, and specifically how to map certain aspects, certain characteristics of a geometric object to columns in that data object. If we actually wanted to do the drawing, we need to combine these two objects. So you can just say print well, actually, I'm going to create a third object. So my plot equals my canvas plus points layer. So I'm going to run all these three. Ooh, I got an error. Yay. Points. I often forget that it's not points, it's point. Okay. So it's created a blank object. It's created this sort of layer that's a set of instructions. It's created a third object that is the combination of these two. But we still don't see anything. We still see that old plot here. If you want to see the plot that you've created, you have to print it. Oh. Aha, there we go. So this is actually one somewhat detriment of, because up here, I could just autocomplete after using Iris dollar. Here you have to write it properly.
If you put Iris dollar in there, will it still work?
Let's see. Well, let me run it first, showing you that it works without Iris dollar, and then we'll explore. So I'll run that whole big chunk again, and ta-da! Got a plot. It looks a little bit nicer than the plot we had before. You can actually scroll through the plots that you've created already with the back button here. So I can go back and see the... this was this failure to plot that we encountered before, and back even further is the actual plot that we created. So there's the fail, back to the one we just created successfully. And it looks a little prettier. The defaults in R are set, in Ggplot 2 are set to be a little bit more aesthetically pleasing and sort of publication ready. But it's certainly then also easier to get to tweak these visuals to your own liking, and there's even what are called themes that make it super easy to steal lots of tweaks and apply them all at once from somebody else. Sometimes journals will actually publish their own themes so that you can just say theme JAMA or something like that, and it conforms then to all the requirements. So, for example, some journals don't like these light grid lines there. Some journals require that there be a border around the plot, things like that. But we'll talk about themes, I guess, well, certainly not today. On yours, you're encountering an error?
Yeah, the non-numeric argument to binary operator.
Say again?
Non-numeric argument to binary operator.
Yeah. I think for the purpose of the class, I think I'm gonna soldier on, but we can talk after class to try to fix anything that you've encountered. So the question was arose: can you put iris petal there and iris dollar petal length there, or what? All right, so let's grab all this, run it again, and it's worked. It's changed the name here, but I'll show you how to change those in a moment anyway. So that's worked. Here's another question. If I go like this, I just don't give it a data argument. Instead, I just give it a mapping argument. What happens? I'm genuinely curious. I don't actually know. It worked fine. Still, even though it's a bit of a pain because you're doing more typing and you also have to remember the names of things, it's a good idea to always be explicit. Partly because I haven't actually used Ggplot 2 without supplying data myself a lot, and so I don't know what cases it's going to start failing. This is the expected way that you do it. It means, though, that you're going to sometimes encounter scenarios where you don't type the name properly and you get those errors, and you'll have to figure out what they mean. So this is an example of having two variables in the two columns in the data that we want to visualize, and one sort of natural way to visualize that as a x and y axes of this thing. If we want to, but we can add other variables and map those variables to other aesthetic attributes. We had in the help, we have plenty of aesthetic attributes to map variables to. So one example is, if we look at this iris data set, we've got species here, and there's 3 levels of species. So why don't we color each of the different dots according to what species it is? So that's pretty simple. We just add something to our points layer here, and we'd say color equals. Now let me triple check. I've got it's capital S species. All right. So having that, I will run that again. And now we've got differential coloring, and we've got a nice little table here indicating what the colors mean. Ggplot is nice in that so you can tweak what these colors are, but the defaults that Ggplot use are pretty nice. There's, again, in the same way that there's themes for defining the different sort of background aspects of the plot, there's actually some themes that set the default scales that are used so that, for example, they will be good for people that are colorblind, or they're good for grayscale only plotting, that sort of thing. So here's an example where we've told Ggplot to map the species column to color, and the contents of that species column was a character string. It was 3 unique kinds of character. What happens if we actually give it something that is a number? So instead of species, we'll say sepal length. What it will do is it will create a continuous color scale. Here, the color scale, the default is to go from a dark color to a light color. And that lets you see that sort of information in the data. In addition to the XY, or the petal length and petal width, you could force this. So whenever, the reason why it's created this continuous scale is because it's gone in the iris data set. It's seen that we want color to be mapped to whatever's here, and it's found what's here is a number. And so it has inferred that we want something that's continuous. You can alternatively explicitly turn this into a character string, and that will kind of force it to treat what it finds there, treat what it finds there as sort of categorical. So let's see. Sometimes when you have scenarios where you only have a few unique kinds of numbers, that can work. Here we've got so many different unique numbers, it actually doesn't really make sense. So this is not a very useful plot. So there's color. Another one we can, so this is an example of mapping aesthetic attributes to properties of the data. And I'm actually going to go back to plotting it by species. And 2, so we get back to this plot. Another thing you can do, so X varies as a function of what's in this column, Y varies as a function of what's in this column, and color varies as a function of what's in this column. But if you'll note, there's other aesthetic attributes like size that the data doesn't vary as a function of, the points we're getting here aren't varying as a function of size. Their transparency, their transparency isn't changing a function of size. The shape isn't varying as a function of the data. I mean, so there's there's obviously some default values being given for these. So for example, shape, its default is circle. Size, its default is whatever this size is. Color, or sorry, alpha, its default is fully opaque. And back when we had the very first plot, without breaking it down by species, color, the default value was black. So what if we want all the objects, all the points to have a different default value for these things? So if there's some aesthetic attribute that you want all of the points to have, you would, instead of supplying it as the inside this call to AES, where it's expecting sort of a mapping from data to aesthetic attribute, you would just type the aesthetic attribute here. So shape equals, there's different shapes. If you look at the R for DS, it has a little table in here somewhere on what the different shapes. The shapes have numbers associated with them, so where'd that go? There we go. So the default is 19. If we wanted open circles, we can say shape equals 1. Let's try that. Shape equals 1. Open circles. Or if we want size equals 2, let's try So this is going to go back to the default shape, but make bigger closed circles. I'm going to delete this line and go back to that original plot that we have. I want you to notice one thing about this kind of plot is that these circles seem to be somewhat regularly spaced. Whenever you see regularly spaced data like that, it's a pretty good idea to, when you're plotting things, tell it to make each individual point semi-transparent. That way, when 2 points are being plotted over top of one another, it looks a little bit darker. That allows you to see that there's not just one point here, there's many points just laid on top of one another. So to do that, you can say alpha equals, and so 1 would be fully opaque, 0 would be fully transparent, so let's just put it at 0.5, so half. So each one is going to be half transparent. So if we run it like that, we can actually see, okay, here's a point over here that is all by itself. Here's a slightly darker point that means that there's 2 points on top. Here's an even darker that probably means 3. So you can't tell precisely how many points are there, but you could tell that there's overplotting.
So that alpha argument that you put in is outside of your aesthetic function,
Yep.
but it still works.
Yes, ditto when we did size and we did shape. When we want to apply the same property to all the points being made, you put it outside, we put it as a separate argument from mapping.
Oh, so the mapping is when you want it to be specific to a certain...
When you want an aesthetic attribute to be data dependent, you put it in the mapping area. If you want it to be just constant, you put it as just a separate argument.
That makes sense.
Actually, I want to see what this looks like. So, I saw a hand there first.
Actually, I just wanted to know, as many times as you're running this command, are we getting new plots or the existing plots are
We're getting new plots, so you can actually scroll back through all the existing plots that you've created.
And when we are exporting, we can save these individual
Yep.
plots, right?
Yeah. Yep.
They're not exported as one PDF and all that.
Yeah, no. You'd have to go through and individually. Now, there is a way to save each of these plots using code. I'll maybe answer this question.
It's exactly the same.
Oh, okay. So anytime you create a plot, you could save it by going into the GUI here and clicking export, save as PDF. But if you've got a whole bunch of plots in a given project that you're creating, you don't want to have your human hand taking time to point and click that whole time. So instead, what you can do is use the Ggsave function. So what Ggsave takes as arguments, one argument is plot. So whatever plot you've created. So we've created this thing called myplot. So we'll say that is the one we want to save. And it takes an argument called file. And that wants a string naming the file to be written. So big one, for example. And the extension you put on the file name determines whether it's going to be a bit, or determines what it's going to be. So if you say .pdf, it saves it as that, a PDF, and specifically it's a vector graphic put in a PDF, so it's infinitely zoomable. If you put it as BMP, BMP, that's one type of image file that's not infinitely zoomable. PNG is another one. JPEG is another that's a compressed version, a lossy compressed type. I always suggest do PDF. There are other arguments that you can supply to Ggsave. Width and length are the ones that will determine sort of this are critical, are the ones that you'll want to vary to determine what size things are. So in aspect ratio. So say width of 8 and length of 4 would make a nice sort of aspect ratio Actually, 8 and 4 is not great, but whatever. You'd want to fiddle sometimes larger values, but the same ratio between the two values. That will resize what the fundamental font size is. That's one way to do things. But yeah, if you're doing lots of plots, then and that you want one and you want each one exported as you go, adding this GG save after each plot is a way to do that.
Where's it going to save?
It's going to save wherever your current working directory is. So during the assignment that we walked through earlier, I changed it to this. So it's saving to wherever the current working directory is. You can actually save it to different places by putting more in this file thing. So if I had, so I'll look in my files area. So this is where the current working directory is pointing. You can actually see in the R console. It says there. Oh, how come the zoom has gone over to this other screen? Anyway, it shows the path to where it's currently looking for files. There, so we know that that's the folder we're doing. So if I created a new folder and I said plots that I wanted to put all the plots into, I don't need to change my directory to that folder. I can actually just say in this plots and then a / and then the name of the file that I want, and it will automatically see that when it sees that there's a plots and a / it interprets that as meaning the current directory, but inside the folder named plots in the current directory, put the file fig1 named PDF. So that's a nice way to organize your projects, to have sort of like a whole plots folder. And yeah. What time is it? 46. Okay. So I've shown so far creating up this object. Let's talk about tweaks that we can do to this object. So if I don't really like that there's, so all it's done in terms of naming these axes is just taking the string that the column name is. Whatever it's being named here, it puts there. Maybe I don't like that. Maybe I want to put sort of petal space length. So what I would do, whoops, not plus there. So label layer. I'll create a new object called label layer, and I'll call the function labs. So for everything that I've made data dependent in any of the layers that I'm creating, I can adjust the label associated with whatever's sort of titling that thing. So for example, there's a axis here that's associated with x. So I can say x equals, so that'll look prettier. Y is data dependent, so I can say color is also data dependent. Notice it has a title too in its little table over here. What do you call it? Legend. There we go. So I can change the title of this legend if I happen to want to. Yeah. So presumably this is millimeters. So color, maybe I don't want that species label there at all. I can actually just put an empty string. So having created this new object label layer, when it hits this line, it's still only going to add together the original canvas and point layer. So I need to add on the label layer. I run this bit. We've gotten rid of the title there. It's now a nice title there and a nice title there. This becomes really useful when you find yourself doing lots of plots of the same sort of generic type, either within a project or from one project to another. You can just copy and paste the code, and you'll get consistent graphics from one to another. Also, if you've done your analysis and it's included one data set, but somebody comes to you and said, oh, I found a few more patients that I want to include in the analysis. You don't need to go through point and clicking, adjusting things to the way you would want, as you would need to do in a lot of other software. You just rerun the code that created the plots in the first place, and it will automatically update to include the new data. So it looks like a lot of, typing to create these plots, when you might be able to do it faster but with a point and click. But when you start talking about lots of similar plots, this becomes a lot easier, a lot more efficient. Let's see, I'm just gonna pull up my notes over here for a second. So there's other things we can do.
Maybe the size is 8 and 4. Is these like in centimeters, and what exactly the size?
Yeah, that's something you just need to explore. It's like, I've never got an intuition of what like unit it actually is supposed to be. Yeah, I think that's actually all I'm going to talk to you about today. I think that's everything that I wanted to do. I guess just as a, yeah, go ahead.
Can you explain that the line which is written on
Mm-hmm.
33?
So, yeah, so what this is doing is it's saying, I've created an object that's just an empty canvas, really, an empty Ggplot object. Independently from that, I've created an object that sort of describes a mapping of, or describes that we want a certain type of image created or geometric object created, and a mapping of that geometric object's aesthetic attributes to features of the data, as well as some changes to the defaults that are set for other aesthetic characteristics, and stored that away. I've also then stored away yet another object that refers to different, I guess, labelable things that might be in a plot, and stored that away. When I get to number 33, I add together all these things. I'll actually put them on separate. So having the plus at the end means that it will still continue the command, so it's okay to put white space. So it's just easier to see in this little window. So when it comes to this, it's going to find this object as a blank ggplot. It'll find this object, which is a description of how to take data and turn it into points. So it will then, having this addition here means that it's going to add these points to this blank object, this blank canvas. And then finally, when it gets to this, it's going to say, okay, any labels that you created in this process, let's change them according to the labels that we've asked for that are new. So when this all runs, we then create a new sort of plot object that we store away in a thing called myplot, so that we can both look at it and then save it later.
So each time we are adding a function, we'll have to come to myplot and add it.
Yeah, exactly. So yeah, you have to remember to add it. So we did it all on one line here. You could have done myplot equals, say, my canvas, my plot equals my plot plus points. You could sort of do it that way. Probably better to do it just all in one go at the end.
My question, for example, label layer equals labs. Labs, that's a function. It's
Yeah.
already been in R, right?
Yes, this is and in fact, so this is a function that becomes available once you load the ggplot2 package.
Same as the ggplot is a function, geom_point is a function.
Yes, geom_point is a function that the ggplot2 package provides. One, I guess, trick since we only have like 2 minutes left. Oh, go
The
ahead.
Ggplot 2, where are the list of functions in it? It's from help. I can find it.
Sometimes a package will create a help page associated with its name. No. That if you just type the name of the package preceded by a question mark, it brings up a nice documentation page. Ggplot 2 is not one of these. So let's actually go here. If you click this, this is the main documentation file, but it doesn't have much here. So Ggplot 2 is not being very nice in conforming to the standard create the nice documentation page for that package. However,
Others are.
well, Ggplot 2, if you type that into R, there's actually a whole website devoted to help with it. And this is actually a fairly well done website, so it's actually... Yep, there's a mailing list with it. Oh, yeah. So this is the actual sort of help page for it. It's actually much better than most R help gets, but it has that one downside of not. It should really have just a single page saying "Go here" for good help. Yeah, that's where I'm going to leave it today. There's lots of geoms. I've shown you a geom that just takes the data and plots it directly. There's lots of geoms that, behind the scenes, do statistical transformations. Geometric object. Yeah. Something that can be plotted in a space. And I'll put this recording on Brightspace. So you should, though, read through that data visualization chapter. It's going to show a few things that I didn't show. It's going to show things that I did show, but in a slightly different way of doing things. So, for example, you don't actually need to create all these objects and then later add them together. You can just call ggplot and then put a plus, and then geom point and put a plus. I like to show people, introduce people to ggplot by creating these separate objects and then adding them together at the end. I think it's more clear for people, but...
If we, when you wrote my plot equal my canvas plus, if we highlight that and press the line, would that work, or I have to do print?
Nothing. It would say I've got an empty canvas. So if we just say... nothing prints. It's just an empty thing.
Sure. But I think what I'm saying is, for the last part, before print my plot, if I just run all these three lines,
Okay, so this is the same as saying print my canvas. If I try to print layer, it's going to print a bit of a summary of the instructions we gave, but it's not going to show anything visually, and ditto. Yeah, so you need to add them together. All right, great. See you guys.